Thank you for joining us today. My name is Dave Cocking and I'm joined by Designbuilder's Managing Director Andy Tyndale. Over the next hour or so, I'll introduce you to the new version of Designbuilder. There will be time at the end, so we'd be grateful if you could hold your text questions until then. For those of you not familiar with Designbuilder, we're a UK-based company specialising in simulation and code compliance software. Designbuilder's core aim is to provide industry-leading software which is both very easy to learn and use and is competitively priced. In doing this, we hope to remove the main barriers so that people can use simulation tools to make buildings more comfortable and energy efficient to reduce their environmental impact. Designbuilder is a graphical front end which enables you to access the power of industry-leading engines like Energy Plus and Radiance in a much simpler and more time-efficient way. The Energy Plus and Radiance simulation engines can be used to perform the analysis to gain code credits for LEED, BREEAM and Green Star, etc. Our interface also enables you to use other simulation engines, for example, to run energy performance compliance calculations specific to different countries in Europe. This means that you can run different calculations using the same model simply by changing the analysis mode. Designbuilder also has its own CFD engine, which is fully integrated with the modeler, again enabling you to use the same model geometry to run CFD simulations. Designbuilder's highly user-friendly dashboard and efficient data management system enables you to quickly produce geometry from scratch or to easily edit existing geometry that you've either imported or created yourself. These qualities help to reduce the risk of modelling mistakes and significantly reduce the amount of modelling time required. I'd now like to show you how.
I'll start by discussing the import of floor plans and GBXML models from BIM tools such as Graphisoft, SketchUp and Revit. Then show daylighting and some of our powerful geometry features before moving on to look at efficient data management, detailed HVAC modelling, various thermal and comfort simulation options and outputs, and optimization simulations. Here's the standard Revit test model, which took a couple of minutes to import into Designbuilder in GBXML format. In addition to the basic geometry, models can be imported with their associated construction data to minimize the amount of additional data you need to input. Having imported the model, we can edit the geometry or data as required. To prevent wasting time waiting for simulations to run, I've taken this opportunity to pre-run a Radiance daylighting simulation. Before we look at the results, I'll quickly show you the calculation options. As you can see, this particular analysis was done according to the LEED V3 calculation, but I could have chosen others, such as BREEAM or Green Star. Setting the report type determines inputs like the working plane height and sky model automatically, which differ between the various codes. The level of accuracy here is set to good. This sets the ambient bounce inputs, but like all of the inputs, those can be manually overridden if required. Here in the lobby at zone level, you can see the illuminance levels on the working plane of the lobby zone. This east-facing facade has high illuminance levels in the morning, with reduced daylight at the southern end, which is obstructed in the model. As expected, in the afternoon, the illuminance levels are much lower. Going to building level, we can see the LEED V3 report. I'll now delete the BIM model and quickly start to talk about 2D floor plans. If we don't have a GBXML file, we can either draw the geometry freehand or import 2D floor plans in a variety of formats. We can import DXF plans from CAD models, or if CAD plans aren't available, which is often the case for existing buildings, then you can import a variety of bitmap type plans such as PDF as shown here. Assuming we have no GBXML or floor plans, I'll show you how to create the geometry for a medium-sized office building freehand. Many of the same tools can be used to edit and refine existing models to prevent you having to redo a model as the design evolves. In Designbuilder, buildings are created by adding one or more blocks. After selecting the Add Block tool, I can either move the mouse manually to define the perimeter wall lengths or simply type in the required dimension. The mouse is moving in 1 meter increments as I have the increment snap set to a 1 meter spacing. I could easily move it freehand. The lines snap to the axes as they're being drawn to aid alignment, but can be drawn at any angle if required. The dotted lines are drawing guides. These are used to quickly line up new points with existing points. Clicking on the green snap point, which was the starting point for the block, will result in a 3D block being automatically extruded to the set height. We can easily change the base geometry that we've created or which has previously been imported. Here, for example, I can use the Orbit tool to access the south facade and then use the Drag Face tool to drag the whole facade by the required distance. Here I'll drag the face 10 meters to the south. Now I have some geometry, I can easily view it in a variety of directions. Here, for example, setting it to plan view. Navigating to the block level, I'll add a courtyard by cutting out the centre part of the section. Construction lines are an aid to creating geometry. And here I'll create a snap point for the start of my courtyard, which is 6 meters in from the north and east facades. I can then simply select the void perimeter tool, set it to the rectangle perimeter shape, and add an 8 by 18 meter courtyard to give a block with a 6 meter plan depth all around. Going back to building level in axonometric view, I can clearly see the modified geometry. I can easily copy blocks using the clone tool. Note how easily I can pick up the bottom of the original block and attach it to the top using the end snap point on the corner. I can cut a block in different ways. One of which is to select a plane as the cutting plane. Like so. Once the block is cut, I can select and delete the part which isn't then required. In addition to editing entire facades, one of our new V4 features is the Add Surface tool. I'll select half of the remaining original north facade. Note how easy it is to select that part of the facade and define the perimeter using the centre and end snap points. And I'll now drag that part in either a positive or negative direction. Here I'll extend it so this part of the facade mirrors the leg opposite to it. Another really useful feature in Designbuilder is the ability to add potentially complex roof shape by defining a few simple parameters. When I add a block using the pitched roof form, I can define aspects like the roof slope and overhang, or whether or not the roof is occupied. I'll set this one to a hip roof by deselecting the gable option with a 0 overhang and 40-degree slope. Using the rectangle perimeter shape, I can very quickly attach a new block to the current flat roof surface with 2 clicks to create this rather impressive looking roof geometry. We can also easily add blocks in different planes. For example, here I'll add a block in the vertical plane and then extrude it horizontally. Using the extruded block form and polygon perimeter, I'll create a monopitch roof with an apex at 6 meters high and the other facade at 3 meters high using the drawing guides. And I'll now drag that block back and snap it to the existing geometry behind. I can now cut that block using the draw plane cutting method, where I draw the cutting plane manually as opposed to cutting by selecting the surface. Here I'll try to make that roof junction a little less pronounced. By selecting 3 points on the roof surface, I'll trim the first 4 meters off the block. This will create a valley between it and the adjacent sloping roof selection. My sincere apologies if I've just offended the architects amongst our audience, as this is rather an odd looking roof junction. I hope you'll forgive me. Obviously the reason is I'm trying to show you a variety of features without creating an overly complex building. At least you can sleep easily tonight knowing that I'm not going to be stealing any of your architectural awards. I can now use another of the new V4 geometry features to create a mirrored copy of the block I've just added. I first select the block and using the mirror tool, define a reflection in the y-axis, in this case, and an attachment point. Then simply attach the new block to the eastern wing using the snap point on the top corner of the opposite block. The final geometry tool I want to show you is the Boolean operator, which now works completely reliably due to the modeler introduced with V4. Before I do that, I'll add an entrance to the north facade, which in this case I'll use the perimeter or the arc perimeter option. And I can define that block very simply with the minimal number of clicks. Having added that block, I'll now join it to the original ground floor block by using the Boolean union tool. I can now navigate to that ground floor block, which you can see is now 1. At block level, I can quickly subdivide the block into zones using partitions. Here I'll create a reception zone in the new entrance area using standard partitions. There is another partition type, the virtual partition. As the name suggests, that doesn't introduce a physical partition or any mass. In this example, I'm just using standard partitions. Once part of the block is completely enclosed with the partitions, the zones are created automatically. So you can see here we have 2 zones, enabling me then to specify their particular features such as the activity type or lighting or HVAC system where relevant. I can now change the zone name to something appropriate like reception. Component blocks are used in Designbuilder for a variety of reasons. Standard blocks are primarily used to provide shading and reflection surfaces in thermal simulations, and ground and adiabatic blocks are used to set non-standard external adjacency conditions. Here I'll draw a standard block on the east side of the building and this will replicate an adjacent building for shading and reflection purposes. I could also model a deciduous tree with seasonal shading using a standard component block with an appropriate schedule to vary its solar transmittance seasonally. I'll now add a simple ground block to set a non-standard adjacency on a small section of the west facade. Adjacency assignment for surfaces in Designbuilder is automatic and is based on the geometry and activity types selected in the various parts of the building. For example, the above ground external wall surface automatically has an ambient air adjacency, so I can use the ground block to modify the adjacency for that part of the wall in contact with, say, an earth bank. I can then view the effect of that ground block on the wall adjacency by navigating to the surface, and you can see where the line of the top part of the ground block joins the original surface. To the left of the Layout tab on the Edit screen, you see the Navigation panel, which shows the different levels in the model from site at the top level all the way down through the building, block, zone, surface and opening levels. We'll talk about our data hierarchy a little more later. I'll now briefly review some of the key model data inputs and explain how Designbuilder's hierarchical data management system can significantly reduce the amount of model data editing required. Starting at the top site level, there are around 6,500 ASHRAE 2013 locations, including design data, and over 2,900 Energy Plus hourly weather files, which are loaded automatically according to the location set. In addition to the various other inputs, the site details include the new outdoor air, CO2 and contaminant settings. To enable us to run a monthly cooling design assessment, I'll change the design temperature period to monthly. The Activity tab is where the internal gains due to occupancy and equipment are defined, and also where we set our environmental comfort parameters. Here you can see the options to set data such as the heating and cooling set point temperatures, the ventilation rates, lux levels and internal gains. At building level, the generic office area template is set. This is the building default, which filters down to all blocks and zones using our data inheritance mechanism. So you only need to change the activity in zones which are different. Here, for example, we have a reception zone. So I can simply navigate to that zone and change the activity to reception. Going to the Construction tab, as with the other data input tabs, the template sets the values below. This is a means of quickly loading bulk data and can be used to load the most appropriate defaults either from Designbuilder's extensive library or your own templates that you've added to the library. Here at building level, notice how all constructions are set to project by default, loaded by the template. I can select a template from the library, which would include the ASHRAE Appendix G library for the particular climate zone if I'd configured this as an ASHRAE 90-point model for lead modelling. More on that later. I'll now load the Best Practice Lightweight template. And now I've done that, you can see how it has changed all of the constructions below, such as the external walls, floors and roofs. Templates can be used to save data for reuse in similar projects, so you can create your own or edit existing ones. Subsurfaces can be applied like patches to replace part of a surface with a surface having different properties, such as an opaque door. The new geometry, areas and volumes data now allows you to use a zero surface thickness or link the surface thickness to the construction build-up, and is a significant improvement over V3. You can either set a zero surface thickness or manually set the surface thickness, or link the surface thickness to the construction data, i.e. the layers data for the walls, floors, roof and partitions. This depends on the template selected. I'll link the surface thickness to the constructions data by setting the external measurements template. Having done that and going to the Layout tab, you can see that with the external measurements convention set, the block and zone walls are shown with a finite thickness. Linear thermal bridging is becoming more important with increasing insulation and airtightness standards, and we've introduced a mechanism to enable you to model this in version 4. You also now have the ability to input early stage design cost data in the relevant areas of the model. I'll now take a brief look at the makeup of the external wall construction. You can see this is made up of 3 layers, each of which comprises of a material of a specified thickness. The data is editable, so you can add or remove layers and change the properties of each layer if required. If I browse to the innermost layer, you can see the extensive list of library data already included with Designbuilder. You can add your own data to the library with ease. You'll notice this library data also includes manufacturer's library information for phase change materials. I can either copy and edit the library data or change it for one of the other materials. The Set U-Value tool is very useful as it automatically sets the insulation thickness according to a U-value that you specify. A condensation analysis tab is also included in version 4. Moving now to the Openings tab, this is where we define the glazing properties. The Facades option here at the top allows us to make bulk changes, such as setting a global window to wall percentage ratio. This allows us to use Designbuilder's data inheritance mechanism very effectively to load the most common data at the building level and only change it where required at the levels below. Facades are used at early design stages or where a common percentage is required. These facades options are set by default, hence the automatic appearance of glazing during the creation of the geometry, which you may have noticed earlier. I'll now change the reception zone to be fully glazed. So I'll set the reception to 100% window to wall ratio, or to fill the surface. We can of course draw openings onto surfaces manually and copy them to other parts of the building. Unfortunately, we have limited time today, so I can't show you everything. Within the Openings tab, Designbuilder allows you to enter full details on the facade, such as the reveal depths, window frames and dividers. We'll now take a look at the glazing type, and I'll open the dialog. Designbuilder allows you to define the glazing using either material layers, as you can see here, so it comprises of a variety of panes and window gases, or using a simplified method, which you can see here, where you just enter the basic solar light transmission factors and the U value. The window pane library includes the full international glazing database with all commercially available glazing types. Designbuilder allows you to define shading in 3 ways. We can either switch on window shading, and this option allows us to specify objects such as blinds and electrochromic glazing, which can be controlled in various ways. I'm now going to navigate to the upper courtyard block level, which I believe is block 2, and switch on local shading to create 1 meter overhangs in that block only. You can see that we provide a library with different combinations of louvers and overhangs, and you, as always, you can create and load your own library data. On the Layout tab, you can see the representation here of the overhangs that we've just added to that block only. Back on the Openings tab, I'll just switch off the local shading. The third shading mechanism uses standard component blocks. So back at the Layout tab here at building level, I can very easily add a semicircular overhang over this reception area. Selecting the Add Block tool, I'll use a standard component block set to a height of 0.1 meters with an arc polygon perimeter, and create a 2 meter overhang in just a few clicks. And changing back to the straight line type, I can finalize that block. So now we've added our geometry and some shading devices, we can take a look at the visualization tools. These can be used for site solar shading studies and also very useful for client reports. I'm going to switch on the SunPath tool and the shadows option, and enable those. And you can see here, using the orbit tool, we can clearly see the shadowing effects at that particular time of the year. I can very easily change the time and period either manually or using the sunpath tool like so. Using that to analyze the shading at various times of the year. Another new tool introduced in version 4 is the section tool. And I'll now take a section through the north-south axis. And in fact, I think, cancel that, I'll take a section through the east-west axis. The original axis is fine. So you can see here that we can see some of the internal shading effects on our floor surfaces. We can also generate video outputs very quickly and easily, which are quite impressive for client meetings. Moving now back to the Edit tab, we'll take a quick look at the Lighting tab. This enables us to specify the lighting gains and any daylight control options. In the HVAC tab, because the simple HVAC model option is set by default, we can very simply define the heating, cooling and ventilation systems. This is a great option for early stage analysis and may well be used by architects before moving on to detailed HVAC analysis, which we'll talk about shortly. As simple as this option is, it still enables us to define operations such as free cooling and heat recovery. Also on the HVAC tab, we have our natural ventilation options. Natural ventilation can be modelled in two ways, using either a simple scheduled method or using the more detailed Energy Plus airflow network, which allows flow rates to be calculated based on wind and stack pressure differences. Both of these can be modelled with or without mixed mode operation. Before I go on to renewables, we'll take a quick look at the earth tubes and various air temperature distribution methods which allow accurate modelling of displacement ventilation and underfloor air distributions, for example. Renewables and on-site electricity generation is another important new feature of V4. You can now model PV and wind generation, including electrical distribution, storage and feeding into the grid. I'll now show you how to quickly set up a PV system. So I'm at building level in the layout screen, and I'll start by drawing a PV collector onto one of the southern roof surfaces. Once I've created it, I can then navigate to that object and edit its properties on the Construction tab. The electrical load centre is then defined on the Generation tab at building level. To do that, or to create my PV system, I can simply copy the default load centre and edit it to use the PV panel. Wind turbines can be defined in a similar way. In Designbuilder, Model Options provides flexibility to tailor the model in various ways. Designbuilder defaults to relatively simple options, but it can add complexity by changing model options, such as setting detailed HVAC here, or calculated nap vent. Once I've enabled detailed HVAC, you'll see the item in the navigation panel. And if I click on that, I can immediately access the list of available templates. HVAC systems can be created from scratch manually by adding and joining your own components together, or as a starting point, we can load pre-configured and connected systems from template using this dialog. A wide range of system types is available, and several more new system types were added in V4. For example, the ground source heat pump system is a full implementation of the Energy Plus ground loop heat exchangers, including the vertical borehole system shown here. This system provides heating and cooling to heated floors and chilled beams. The ground heat exchanger links with ground loop design software for loading G functions. Another new system included in V4 is the solar hot water system. The solar assisted heated floor system selected here provides heat for heated floors through a 2-tank system with auxiliary heating provided by a boiler. You'll notice that systems are provided for all 10 ASHRAE 90.1 Appendix G baseline systems. I'm going to load the fan coil unit with DOAS air-cooled chiller template to the model. Designbuilder detailed HVAC uses zone groups, so we can decide which zones we want to include in the for that particular system. The zone group contains a number of zones, allowing systems to be connected once, with Designbuilder automatically managing the connections to the zones. Although this system was loaded from template, it's still fully configurable, and components can be added, deleted and edited as required. For example, I'll open the chiller plant dialog. You can see the chiller template library of air and water cooled chillers, including a wide range of manufacturers' data, as well as a few generic types. Reformulated EIR chillers were added in version 4. Energy Plus uses performance curves to define variations in component performance as the loads, temperatures, flows, etc. vary. Designbuilder V4 provides a graphical display of this performance data, as you can see here. Another important new feature in V4 is economic analysis. 3 methods are provided: tariff analysis for operational costs, construction cost, and life cycle cost, which includes both of these costs over the life of the building. I'll show you very briefly the tariff analysis dialog. And we can edit its characteristics here. So Designbuilder includes the full set of Energy Plus tariff analysis options. Life cycle costing allows you to consider the cost of the building over its entire lifetime for a more holistic analysis. Designbuilder now includes a full implementation of the Energy Plus lifecycle costing capability. You can input data for recurring, non-recurring, and price escalation. So now we've set up our geometry and configured our model data, I'll move on to start looking at various calculations and simulations that can be undertaken in Designbuilder. The first of these is heating design, which is a very simple steady state calculation for determining our heating plant loads, so I won't look at that. For sizing cooling systems based on summer design conditions, we can go to our cooling design tab here and set up our calculation options. We can select the assessment period to ensure we identify the dates with the highest likely cooling loads, and also set data such as the design margin and sizing method. Although the cooling design calculation is dynamic, the cooling design calculation does run relatively quickly. So, here in the Analysis tab, we can see useful design data like the half-hourly heat balance and cooling system loads graphs. We can view the results in different ways, such as grid data, which can be exported to a spreadsheet. And we can also select whether we want to see the data for a specific month, or whether you want Designbuilder to display the data for the peak month automatically. I might want to view, say, only the internal gains in one specific zone to enable me to make sense of how particular areas are performing. So here in our reception zone, we can see relatively large solar gains, and we may then want to consider the introduction of solar shading devices to reduce our loads. On the Summary tab, the table shows the design capacity and flow rate data for either coincident or non-coincident loads. Moving now to the Simulation tab, we can run simulations using hourly weather data over a whole year or part of a year. I'm going to set up a Summer Design Week simulation. I can define a range of calculation and output options. On the Output tab, there are some new comfort options, which you can see here. I'm also going to select HVAC node data so we can view the temperatures and mass flow rates within the HVAC system. I'm going to run this simulation using the new Simulation Manager by selecting the option on the Simulation Manager tab. The Simulation Manager is an important new feature which allows us to queue and run multiple simulations in parallel. Simulations can be run on the local machine or on a network simulation server, and we've also been testing cloud options, but cloud simulations aren't generally yet available. So in a moment we'll see the results set loaded into the Simulation Manager here. Okay, apologies for that brief interlude. So we've loaded the standard results set into Designbuilder, but we could also load them into the new results viewer. Here you can see a range of results displayed by default here at building level, including fuel consumption, temperatures, the heat balance, and the other options below. There is also a summary tabular output with a range of useful report options already set up. So I'll now move on to take a look at, or to discuss, optimization. Optimization itself takes a little time to set up and configure, and it's necessarily detailed. So I'm just going to give you a sense of optimization by referring back to a study that we did recently from a PDF poster. So our new optimization tool allows us to carry out multi-objective optimization studies with constraints and up to 10 design variables. It can identify which design options have the optimal combination of cost, energy and comfort performance. This is a poster that we presented at the CIBSE ASHRAE conference in Dublin earlier this year. It shows how various aspects of a passive solar design were optimized so as to minimize operational carbon emissions while also keeping costs at a minimum with constraints on occupant discomfort. The optimization graphical outputs help the designers to decide the priority to be placed on the design objectives. For example, in this graph, the red points show the Pareto front. containing the optimal solutions which give the lowest combination of construction cost and operational carbon emissions. The trade-off between cost and carbon can be seen very clearly, as well as the impact of the decision on lighting system choice. A quick look at this graph might help the designer to home in on the fluorescent lighting system with daylight control as the most cost-effective system. There hasn't been time to show you the details of how the ASHRAE 90.1 features work, but I can just briefly describe the functionality. Designbuilder version 4.1 provides the first installment of the Designbuilder lead capability, which includes the main underlying functionality for simulations based on the ASHRAE 90.1 Appendix G standard. All constructions, materials, glazing systems, activities, lighting and HVAC systems required for ASHRAE 90.1, 2007 and 2010 are included and automatically set based on the climate zone within the Designbuilder modeler. Detailed HVAC systems are provided for all HVAC system types required for Appendix G baseline buildings. Once loaded, systems can be tailored as required to meet particular requirements of your building. For example, adding multiple chillers for large buildings. The Energy Plus LEED summary report provides the LEED energy credit data required for the LEED energy credit submissions. Further improvements will be added within the V4 development cycle, including tools for automatic baseline building generation and simulation of the 4 baseline orientations and averaging of their results.
Unfortunately, that's all we have time for today, but if you want to submit text questions, we'll do our best to answer as many of them as we can in the next few minutes. This webinar was recorded and you'll receive an email with the relevant details should you wish to review it. There are lots of other free resources available on our website or on YouTube, including past webinars and more detailed video tutorials. I'll now hand over to Andy to review and answer your questions.